Coming up, we cam the touring
gingerly.
Clutch upgrade.
Let's check out the difference in the weight.
We DIY paint wheels better than some pro shops. And how much power do performance upgrades actually bring? Welcome back to Project Cologne, former daily driver now turned track tool for the Nürburgring. Over the last few episodes we've done a bunch of track related upgrades, and in this one we're still doing that, but also chasing more horsepower. The 3-liter inline 6-cylinder engine in the E46 Touring is ready to receive upgrades, but first we need to establish a baseline. We are putting Project Cologne on the lie detector at Brabham Performance to find out the power number of the stock M54 B30 power plant. After each upgrade, we'll come back to this exact dyno. You can go to 10 different dynos and get 10 different results. Hence the importance of sticking to the same one to get clear before and after comparison and accurate results of each mod. The graph is showing HP, but the results are actually in PS, metric horsepower, and here's what we are working with. 221.6 PS at 6,350 RPM and 275 Nm of torque at 4,950 RPM with a stock tune. That's our starting point. Let's see how many more donkeys we can extract from the mighty M54 Tower of Power. After a slight and quick remap, we landed at 226 PS and 278 Nm. 4.4 PS more, which is hardly worth mentioning, but hey, you gotta start somewhere. The first upgrade that we're doing won't gain us any power, but it will make the engine a lot more responsive. This being a 6-speed manual car, a single mass flywheel is the way to achieve that. A dual mass flywheel, which is what the car currently has, is primarily designed to absorb vibrations and make the car more user-friendly for daily driving. But the downside is that they are quite heavy. I got a clutch kit and a single mass flywheel from PTB Racing. The single mass flywheel weighs around 5.5 kilograms, while the dual mass flywheel is around 12 kilograms. This means that the energy required to spin up a dual mass flywheel is much greater than with a single mass one. Less rotational mass equals to an engine that will rev up quicker, easier, and be more responsive, which is what we want for the track. Now, a single mass flywheel will transfer more vibrations through the input shaft into the transmission and cause gear rattle, aka gear lash noise. This manifests itself as chatter or rattle on idle with the clutch engaged, and also around 1500 to 2500 RPM when accelerating. There is no way around this when using a single mass flywheel, but there are some things that you can do that can help with NVH. Noise vibration harshness. It's rather important to use a sprung hub clutch disc in combination with a single mass. The springs in the hub will dampen the forces, reduce noise and vibrations, and make it generally easier on the entire drivetrain. The second thing that helps is the gearbox fluid, which we'll get to later in the video.
Now we need really long extensions. Alright, so fantastic. Okay, that's all the bolts removed. Okay, I think we are clear. It's out. All right, let's see if I can drop it on my head officially. That was a lot of work. Let's get the clutch kit and the flywheel off. It's out. That looks fairly new because it is. Next, the flywheel. Flywheel is heavy. Be careful. Let's check out the difference in the weight. This is the stock dual mass flywheel, 11.7 kilograms. And now the single mass flywheel, 5.35. Huge difference. This is the supplied pilot bearing. Just knock it into place. That's in. The flywheel. Medium thread locker on the flywheel bolts. Drive the bolts in. This clutch kit comes with installation instructions. The torque for the flywheel is first 30 Nm, then 60 Nm, and finally 128 Nm. torqued. Clean the flywheel surface. Now we need to line up the clutch plate. Like that. Grab the pressure plate, which we also need to clean. Okay, it's in. Medium thread locker.
I initially went with a sintered clutch disc, which was a mistake. The sintered disc is notably stronger than a normal organic disc, and it will last a lot longer on the track, but the engagement is literally like an on and off switch. Works great on the track, but makes the car unusable on the road, and setting off from a dead stop is just a very unpleasant experience. I quickly got tired of it, and later I swapped in a normal organic clutch. I'd recommend a sintered clutch only if your car lives 99% of the time on the racetrack.
Tighten it in a crisscross pattern. Take this out now. All right, 2 big side bolts are in. Now I gotta start the rest of the bolts. A very, very painful process, and torque down everything to spec. And now the hardest part, starting the 2 bolts on the top. So I have a piece of paper holding the bolt in. Oh, I think we have a bingo. All right, now I gotta get the starter bolts started. Fantastic. All right, the rest I'm gonna do off camera to speed up this miserable process.
So, the first power upgrade that I've done was oh no. It seems that I'm not able to tell you cause reasons. But anyway, back on the lie detector, the engine was somehow breathing out better, and we got 234.5 PS. Then, Thailand from T21 Industries got to work. All tuning was done by him, and let's just say the man knows how to properly tune an engine. After a bit of time and fettling, we ended up at 241.7 PS at 6500 RPM and 296 Nm at 3750 RPM. A solid gain of 20.1 PS. We are heading in the right direction, so let's do more. The next big power upgrade, the camshafts. For €1,260, I bought these Shriek cams with the most aggressive profile that they offer. Most websites claim that these should net us around 22 to 25 PS more. Well, let's install them and find out.
So this is the cable for the oil pressure sensor, which we can disconnect here. Throw it over there. Let's get the electric fan out of the way. Let's get the ignition coils out. Okay, I'm gonna disconnect the battery so we can get this cable out of the way as well. I think you've seen me remove the valve cover on the M54 engine about 3 million times by now. All right, now I'm gonna use compressed air and just blow out all around the valve cover so we minimize the amount of crap that goes into the engine. Say hello to camshafts. Now we need to remove the vanos, but the first thing we're going to do is set the engine at TDC, top dead center. Scusi. That should be top dead center now. Let's remove this cover here. There it is. I have an aftermarket vibration damper, but you know the engine is a TDC when the 0 lines up with the mark in the timing cover over there. And also when camshaft lobes and cylinder number 1 are pointing upwards like this towards each other. And you can also see the 2 dots in the back there and there. Now we can proceed with the Venus removal. Unplug a connector here. Then another one here, as well as this one here. Remove the bracket here. Unbolt the Venus line. Remove the bracket. Close off the Venus line. And because you watched the previous episodes, you know that this is a brand new Venus unit from Propston Tech, from York. Yee, there's the oil. Pull out the cap. And now we have counterclockwise Torx bolts there, like that. And now we can start unbolting the Venus unit. Put this somewhere safe. Now I need to lock the cams, so I'm going to remove these 2 studs in the back. So this is the block from our timing tool kit. This needs to sit flush with the cylinder head. Yep. So rotate the cam to get the tool to sit flush with the cylinder head here. Just like that. Then we have this plate here. You can also lock the engine at TDC at the flywheel, but we're not going to do that because I'm going to rotate the engine slightly when we start removing the cams. And we need to retime it anyway. Okay, grab this pin from the timing tool, press down on the tensioner here, and lock it down with this thing. Like that. Now we can loosen up all of the bolts and nuts in the front. And this is E-Torx, E8. Now we need to remove the timing chain tensioner, this guy here. It's 32 mil. You can't, it's very tricky, there isn't enough space. Okay, I'm gonna give it a couple of smacks. Okay, there we are. So that's the tensioner out. Now let's get the gears off all the way. Make sure you don't drop anything into the engine. That would be extremely bad. There's a spring here, a spring plate. It's marked F for back, for rear. No, for the front. And then another one. I'm going to keep everything in order as I remove it. Now I'm going to remove the cups here, and this one. And now keep the tension on the chain here, the sprocket, and pull it out. Now I need to remove the tensioner. Now the bottom rail tensioner thingy. Ooh, this guy's long. Remove the studs here. Make sure you're holding the cam when you're loosening these bolts. Studs, that is. So, free the chain. Now I'm going to secure the chain here. The chain is secured in place. Remove this plate here as well. Hold the cam. Now, the next step you can skip if you're dealing with stock cams, but because we're installing Schrick cams, we need to remove these helical gears here. We need them to put them on the Schrick cams, and to remove them, we need to release these two bolts here. Now grab a big wrench so we can counterhold the cam. There's a slot here in the middle of the cam, T50 here. So be careful here and make sure you counterhold it, otherwise we can break the cam. There we go. And we're going to need a special tool to install them on the Schrick cams, which I'm going to show you later. And this is a very special bolt. You can't buy this in a normal hardware store because it lets oil flow around it as well. So here you have a slot where it goes back in, but the Schrick cams don't have that. Now I can get down with the business of removing the cams. So remove the timing tools from the back. Okay. So first thing that we need to do now is rotate the engine counterclockwise around 45 degrees. That way the pistons are going to be far away from the valves and it's going to be much safer to remove the cams. So grab the chain here. Like that. Now we're going to rotate the cam clockwise so we have the least amount of lobes pressing down on the valves and the lifters. So now I'm going to try to find the best position here, because now we have cam lobes on A3, so all of the caps are marked here, and A5 pressing down on the lifter, and we want to find like a middle ground where they both slightly pressed. All right, something like that. So now we have only lobes on A3 and A5 pressing down on the lifters. So all of the caps are marked, A1, A2, 3, 4, 5, 6, 7. A stands for aus, as in exhaust, and then intake, it's E as in Einlass, which is intake. And now we can remove the caps on A7, A6, A4, A2, and 1. And then we're going to slowly undo A3 and 5 because they're still pressing on the valves. I'm going to leave cap number 1 in place, but the rest we can remove. Now we can start releasing these two caps, quarter of a turn in a crisscross pattern. So the first cap should start lifting. We need to do it like this so you don't twist and break the cam. Okay, I can see the cam is lifting evenly. And just like that, it's free. And now we can lift the cam out of the way. There we go. So fun fact, I was actually planning to replace the lifters because, well, in there, but I forgot to order them. And if I were to place an order now, it's gonna take a few days before they get here and I don't have time to wait. So we're gonna reuse the old ones. There's nothing wrong with them. They're not ticky or anything like that, so should be fine. Now we have a very clean finger and assembly lube from Liquid Moly. And we're going to apply that on the lifters and the seats as well. So just a quick spot of cleaning here. Brilliant. I thoroughly cleaned the Schrick cam and covered it in fogging oil for men, and now we're going to install it the same way we took the old one out. Gingerly. 1, 2, 3, 4, 5. Lubed up caps as well. All right, that's all of the caps started. Now we're gonna go slowly in a crisscross pattern and tighten all of them nicely and evenly. That's the caps finger tight. I'm gonna try and turn the cam just to make sure everything is okay. So you can see that the cam is turning, which is good. So we can torque down the caps. Beautiful. Now we can turn the cam backwards. Great. Now let's attack the intake cam. The procedure for the intake cam is exactly the same. Position the cam to the point where you have least amount of pressure on the valves. So I think if I turn it this way. So E4 and E6 we are going to undo the last. All right. So half a turn. Needless to say, make sure you don't mix up the cams and you don't install the exhaust on intake and intake on the exhaust. You know what I mean? Yeah. Nice. Let's rotate the cam. Cams installed. Next we need to install the two helical gears, and to do that we need this special tool which you can rent from Jorg from Probston Tech. It is very crucial that these gears are installed correctly and there are no markings on the shriek cams, so the only way to do that is with this tool. First we are going to lock the cams. Make sure that's sitting flat with the surface. Just like so. Good. So let's start with the intake cam. You can see here on the tool that it says intake. That needs to line up with the lobe here on the first cylinder that's pointing up. So grab the screws. Hopefully you can see intake here. It's stamped in small letters, but that needs to line up with lobe on cylinder number 1. And now this thing can slot in only one way. Should be like that. That side goes in. Grab the bolt. The torque speculation is 40 Newton meters and then 60-degree angle. So grab the camshaft in the back. So let's see if I can do this because it's difficult. You have to be at torques, huh? And that's 60 degrees. So remove the tool. So same thing on the exhaust cam. Line up the exhaust mark with the lobe there. All right, 60 degrees. Thank goodness Jorg told me about this, otherwise I would have been stuck now. It's kind of silly that Schrick doesn't provide a tool or the bolt or instructions how to do this. Now I'm going to put the engine back at TDC. At this point we want to lock the engine at TDC by inserting the pin through the oil pan into the flywheel, but we have an aftermarket flywheel and it doesn't have a slot for that. So the best I can do is just line up the marks on the vibration damper and the timing cover and time it that way, which will also work. You just gotta make sure you're very precise. Now you're gonna grab the sprocket for the exhaust cam, and we have an arrow here on the sprocket. This needs to line up with the top of the cylinder head here. So that's not right. So you need to pull the tension from the chain here on this side, because the tensioner is gonna take up the slack here. This is not correct. I think we need to slide it by 1 tooth. I think that's about right. So you can see here when I take up the slack from the chain, this arrow is lining up with the cylinder head, which is very good. We have this plate here. Goes like that. And then this thrust washer, as the repair manual calls it. The torque spec for those bolts is 20 Newton meters. And make sure you're using a clean socket when working on the bolts that are inside of the engine, because that way you can transfer dirt, dust, sand, and whatever else onto the bolt, and then it's going to end up in your oil. Now you're going to use the tensioner from the timing tool to put the tension on the chain. The repair manual says 0.7 Newton meters, and that's pretty much nothing. So just go finger tight like this, and that's it. And now you got to make sure that this arrow here is perfect in line with the cylinder head, which it is. We have 3 studs here. Have a brand new rail for the chain here. So the longer bolt goes there, and the smaller one goes here. The new tensioner. Now we need to put back the sprocket with the cup, and this goes in only one way. We need to line up the splines and then pop it in. There it is. So the repair manual says to push the cup until the holes here are centered, threaded holes. So you can go all the way in, and that will be the middle. Now we have the secondary chain in the sprocket. I am going to clean this a bit first. So pop this into our tool here. And that goes there. Have a brand new chain here. So this slides, so you can put the chain on and then take up all of the slack. Fog it up with fogging oil from men. Install this cup as well. And now you can grab this and transfer it over onto the engine. So first, I'll line up this cup here, because it goes in only one way. Oh, there it is. It went on. So now this cup, we need to push it out to the point where you can just about see the splines. So 1 millimeter out. Go with that. Install the plate. And you can see that there's front written on it. Start the nuts, but do not tighten them. Now we can install the screws here. The repair manual says to torque them to 5 Newton meters and then slacken them off. And I'll loosen the bolts. Then we have the thrust washer. Then the cup spring. So the F needs to point towards the front. Now we have the cam position sensor gear. You can see an arrow here that needs to line up with the top of the cylinder head here. And we can set the nuts loosely. Now we need to pull out this cup here until it stops. So it goes in all the way. And that would be the stop here. This one here, as we said, 1 millimeter out. Remove the pin from the tensioner. So now make sure the bottom tensioner for the chain is tight. Basically, as soon as you start feeling some resistance, you are there. Now it says to preload the cup slightly by tightening these nuts by hand. Now make sure the gasket here is removed, and then we can install this tool from the timing tool kit. Now as we tighten down the tool, it's going to push on the cups and set them to the correct position. See the cups going in. At this point, you want to make sure we are still at top dead center and that the cams are locked and we are good there. Now we want to do the initial torque of 5 Newton meters, starting with these bolts here. I want to torque the E46 bolts to 20 Newton meters and 10 Newton meters for the rest. And that's the timing set. Now remove the cam locking tools in the back. And if you lock the flywheel, you need to remove the pin now as well. And now we need to rotate the engine at the crank twice. So 2 full rotations, and then verify that the timing is set correctly. So leave this tool on. If you remove it, these cups are gonna pop out. Bit of fogging oil for men for the cams. eau de parfum. You wouldn't believe how many cans I go through of this stuff. Then for the chain as well. All right, the spark plugs are in, so we're gonna have compression. This one full rotation. We're coming up on the second, just need to line up the marks. You see that the lobes are pointing up at each other. So grab the timing tool, and if the blocks rest flat on the cylinder head, the timing is correct. And they do. The repair manual says that 1 millimeter is allowed on the inlet side, but nothing on the exhaust side. But here it's sitting flush on both sides, which is spot on. The timing of the engine has been set correctly. I am going to do it one more time, maybe even 2 more times, just to be sure. But that's how you time the M54 engine. I verified once again that the timing is set correctly, and now we can remove this tool and reinstall the vanos. New gasket. Pop the vanos in. The nuts. Now the counterclockwise bolts. These are torqued to 10 millimeters, but I'm gonna go by hand because I have a pretty good feel for it. Don't go too crazy, just make sure it's tight, you know? So you can feel it bottom out, don't overdo it. All right, brand new caps here. The screw plugs. Connect the vanos line. Mustn't forget about the chain tensioner. Tensioner with a fresh gasket going in. We need to give it a good twist. So not crazy torque, just the crush washer needs to be crushed. Clean up the surface. More oil for the homies here. Cover. Bit of RTV where the vanos meets the cylinder head on the half moons as well. And then same thing in the back. As usual, I prefer to smear it. That way we have a minimum squeezing on the outside and inside. Clean cover with brand new gaskets. Now, do up the bolts in a crisscross pattern. And you don't need a torque wrench here. You're gonna feel when the bolt bottoms out. Done. All right, I buttoned up everything, but before we start here for the first time, I'm going to drain the oil because right now we have 5W50 full synthetic in there, and I wanna put mineral oil so we speed up the braking process of the cams. Oil looks good. No metal shavings, unlike a certain Italian stallion. And we are torturing this thing on the Nürburgring. Yet it's working absolutely fine. We are going with 10W40 mineral oil from Liqui Moly. We want to use that so we can allow a bit of wear to happen in the engine, specifically so that the camshafts can bed in properly. And that's going to be much easier with mineral oil than with synthetic oil. Always pre-lube and pre-fill the oil filter housing whenever you can. When it comes to running in brand new camshafts, it seems that everyone has their own preference. A lot of people say that you should start the car and immediately hold the revs at around 2,000–3,000 RPM for like 20 minutes. To be honest with you, I don't really like that because it seems you're putting a lot of wear at once. And I'm simply gonna do what I did with Project Frankfurt when we built the engine from scratch, because I know that worked really well. So mineral oil, and then I'm just gonna take it easy for the next 300–500 kilometers, not put a lot of load on the engine and kind of slowly bed in the cams. After 300 or so kilometers, I'm gonna dump this oil, put 5W50 in it, drive it a little bit more, then do another oil change, and after that we can send it, you know. Now I'm gonna start the car, and I am going to hold the revs at around 2000 RPM for a few minutes, because that's gonna spin the pump faster and we're gonna have higher oil pressure. After that, I'm just gonna go and drive it. The idle is probably gonna be very lumpy, because this cam is very aggressive. Should sound like a V8 muscle car. Okay, oil pressure is 4.5 bar, just like Maserati. Sounds good. Let's hear that choppy idle. You can actually hear the cam. So the idle is definitely not gonna be smooth with this thing. We still need to tune it and whatnot, but as I said, first we need to bed in the cams, and then Thailand from T21 is gonna do the tuning. But so far it sounds peachy. Exhaust. Yeah, baby. I'm gonna button up everything else and start bedding in the cams.
With the break-in period done and the initial tune uploaded, it was time to hit the lie detector again. And the result is 253 PS, a measly gain of 11 PS. Not good, and more tuning is needed. Now, you often see people showing how they tune a car in 15 minutes on the dyno, but I'll let you in on a little secret. That's not a real thing. You can't properly tune and map a car that quickly. I ended up buying an air-fuel ratio meter, connected the wideband O2 sensor to the exhaust, and Thailand remotely tuned the car on the road. And the final result is 270.7 horsepower at 6,934 RPM. Bear in mind that the red line is at 7,100. That's peak power essentially at the red line. The torque, 294.5 Newton meters at 3,887 RPM, while previously it was at 5,000 RPM. This is a fantastic achievement on a naturally aspirated engine. We gained 49.1 horsepower with 2 mods. And just look at the curve. I can't tell you how good this engine feels now. And that's all thanks to Thailand, who spent a lot of time fine-tuning the map for this car, and the result shows. The master of his craft. And that, my fellow petrol heads, is how you achieve more power on an M54 engine. Next up, the control arm bushings. I previously installed Darrell-in bushings, which are solid and prevent any deflection that you get with standard rubber bushings, but they were walking in the bracket far too much and knocking on the ring constantly under hard cornering. I decided to try Rogue Engineering bushings with CNC'd alu housing and high performance urethane, which are also fully serviceable as they have grease fittings.
Clean the control arm, silicone spray. So the bushing needs to sit flush with the end of the control arm. Something like this. Now we have silicone grease, and we need to generously lube up the bushing. Yes. And also the housing of the bushing. So housing lubed up. You can try to push it on. I think it's finally good. Yep. So once it's fully seated, you should be able to turn the housing like this.
Rogue bushings still maintain the much needed minimum deflection, turn-in, brake stability, and direct connected feel with the front end is spot on with these. I think these are a great performance upgrade without a significant increase in NVH.
Nice. And now we have this nipple here where we can squirt silicone grease in there and keep this bushing lubed up. Now we're going to replace the steering wheel. We are going with the Alcantara one that's sitting on the table over there. Normally, I don't like Alcantara on the steering wheel because it just gets nasty over time. But I feel like it's a worthy upgrade for the track because leather, it's kind of slippery. My hands are sweating and then, I don't know, I want to try Alcantara, okay? We'll see if I like it or not. There it is. Another thing with this particular steering wheel, it's been reupholstered and it is super thick, like a lot more than the stock one. And I really don't like that. It doesn't feel that nice in hands. Alright. So here's the new one. Line up the marks. This one has been obviously reupholstered as well, but I had it done to be as thin as possible, so thinner than the one that we removed. And the link to the guy that did this is in the description. He does very nice work. He did quite a few steering wheels for me, including the one for the Alpina. Good and twist. Okay. I got it in there, there. There we are. I'm gonna reconnect the battery. It's working. Perfect. All right, this feels quite nice, and it is thinner than the last one, so nice. This should get disgusting in about half an hour on the track as I touch the bits of the car and greasy and dirty hands. We're gonna have to clean it a lot. That's what I'm trying to say. It does look really good, and I went with black Alcantara and black stitching. I don't know, M stitching just seemed a bit too much there.
Another worthy upgrade to improve the driving experience, even if not used on the track, is the clutch pedal. The stock clutch pedal is made of plastic, it's flimsy, and the travel is far too long. So here we have a billet aluminum short throw clutch pedal from Rogue Engineering that we're going to install.
So here's what we have here. This is obviously the clutch pedal and the brake pedal. The first issue is that the clutch pedal sits a lot higher in relation with the brake pedal, and the most annoying issue is that there's quite a lot of travel here in this pedal, despite me having a clutch stop over there, and the clutch bites at the very, very top. So press it like that and it's gonna start biting. And that's really annoying when you're changing gears. So we're gonna address that issue, well, all of those issues, with the short throw clutch pedal. First, we need to remove this plastic cover here, a couple of Phillips screws, and one plastic rivet over there. Then turn this clip here, slide it out, unplug the connectors, for which I need 2 hands. With that unplugged, remove it and throw it away. With that out of the way, here's the clutch pedal. This is the clutch master cylinder. We need to remove the spring here, unclip the master cylinder, and then there's one more pin on the top and we can remove the entire clutch pedal. So here's the old stock clutch pedal removed. You have this plastic pin that you need to pop out. Just squeeze the tabs here, pull it out, and then you can release the clutch master cylinder. On the top you have this clip that you need to remove and then slide out the whole thing. And then you'll find typical crappy BMW plastic bushings. These are really thin and flimsy, and if you ever experience side-to-side play in the pedal, this is the cause. So try and replace them with like brass bushings or nice solid bushings like this. So here's our beautiful Rogue Engineering short throw clutch pedal. First we need to install the pad here. And then this plastic clip is replaced with this beautiful pivot screw that simply screws in, and it's much easier to remove. And then on the top we have solid bushings, and then we are reusing the old clip. And this bracket here, this is mainly for the US spec cars that have the clutch sensor, so you can't start the car until you press in the clutch. Euro spec cars don't have that, so I'm not going to use this bracket. So all of this is garbage. Okay, we're going to use a bit of thread locker here, the screws, like that. Good and twist. So for the bushings, we're not going to use silicone grease because silicone grease attracts dirt. Well, it attracts dirt that's going to stay there. So we're going to use PTFE pulver spray, which is like permanently dry lubricant. Works really well. and it's not going to attract any dirt. Well, the dirt is not going to stick to it because it's dry. So pop that in, there and there. And now we're going to transfer over the rubber pad. Just need to clean it first. Here it is, a bit cleaner. And this is ready to go back in. And here's a direct comparison, stock pedal versus Rogue Engineering, and you can see how much higher the stock one sits. So this is going to be flush with the brake pedal, which is what we want. And here's how the new pedal sits. It is the same height as the brake pedal, and I am thrilled about that. Let's see what the new pedal feels like. Oh yeah, that's the stuff. Considerably shorter than before, but it feels great, you know. It's not too long, it's not too short, it feels perfect. Let's start it and see where the biting point is now. Ooh, halfway. It's not at the top. All right, that's amazing. So maybe we don't need the new pin for the clutch slave cylinder. I like this. Halfway is exactly what I want, because then I can precisely control the clutch and know where the biting point always is. Okay, you know what? Let me go for a quick drive, see what the clutch feels like, and if I like it, I'm gonna leave it like this. Just came back from a test drive. I further adjusted my clutch stop, which is actually a door stop that I got from a software store, but in this application it's a clutch stop. And the clutch pedal is absolutely perfect. I don't need to adjust anything further. So short travel, it catches right about there, somewhat in the middle, and this is exactly what I wanted. The old one was catching like here, super high, and it was super annoying. So this is an absolute perfection when it comes to clutch engagement and clutch feel. In the previous episode, we went to track speed to get proper wheel alignment, and that's when we learned that in the rear left corner of the car, the toe couldn't be adjusted at all. Two possible causes for that: bent upper wishbone, which I just eliminated. Here's a brand new one, and I just measured it up against the old one, and the old one is fine, it's not bent. The second possibility, bent trailing arm, and we have a winner. This is the old one that I just removed, and if I measure from the center of the bolt here up against the edge of the wheel hub, we have 43 centimeters. Here's the replacement one that M Parts from Netherlands just sent me, and this one says 44 centimeters. The old one is bent by whopping 10 centimeters. I don't know how that happened. This is a solid piece of steel, and unless you hit the curb, how are you gonna bend this? But apparently it is. Well, it's not a common issue, but I had several people telling me after that video that most likely I have a bent trailing arm. And this came out of an accident-free car. That being said, it is 20 years old, so who knows what happened in the past. A shout out to M Parts for coming through again and providing me with a proper, good used parts. So now I need to transfer over the ball joints from the old unit to the new unit, press in a brand new wheel bearing because the old one is not transferable, and then paint this. I hate doing the same job twice, but in this case, what can you do? It is what it is. And at least we found the issue. I'm gonna do all of this off camera because this is a miserable process, which I've already documented once.
Track Speed did wheel alignment in the previous episode, but because of the bent trailing arm, we were severely limited. With that issue fixed, I went back to them. Bill did a more appropriate track alignment, but the next limiting factor are the tires. We currently have Michelin Pilot Sport 5 tires, which are road tires, and they were very grippy in the beginning, but after more than 20 laps, I cooked them and the front end was losing grip. I was understeering pretty much in every corner, so it was time for proper track wheels and track tires. For wheels, I decided to go with Pro Track wheels as I like their design, and more importantly, they are TÜV approved. Project Cologne has a rather odd setup with the complete M3 suspension on a non-E46 body. This is a bit of a problem as the track width in the front and the rear is wider by 37mm and 47mm respectively. The M3 has wider arches as a result, but the Touring doesn't, and this is limiting our choice of wheels and tires. I popped over to Pro Track where we spent time test fitting various wheels and tire sizes until we found something that fits without rubbing. We ended up with 9-inch wide rims all around with 245/40 18-inch tires. A nice square setup. Thank you to ProTrack fellas for taking the time to figure out the right setup for this car and for giving me a small discount on the wheels. As you can see here, they have about 16,000 wheels in stock, which is remarkable. But as my luck would have it, they didn't have a set of wheels that I needed in silver. Only black. And I would rather eat my own slippers than put black wheels on one of my cars. Regardless, I had to buy them and I decided to paint them myself to silver with fully attack 2-component paint. You've seen me use this stuff many times to paint the brake calipers. I kept buying this paint because it works great. Foliatech spotted that and decided to officially support the channel with their products, for which I'm very grateful and very happy about. First, I scuffed up the surface, which was rather satisfying. I don't understand the point of black wheels, and why would anyone want to make the design of the wheel essentially invisible? But anywho, then I cleaned and greased the surface and started laying down the paint. It's a very easy and friendly paint to use and pretty much impossible to have paint runs. The key is to apply many thin layers, and once the paint fully cures, you'll end up with a strong, durable finish. To me, this stuff is like powder coating in a can. I can genuinely say that this turned out better than some wheels that I had professionally painted in the past. You'll be happy to know that there are no imperfections in the finish. For the tires, our friends from Michelin came through with the best of the best. Michelin Cup 2 tires. Semi-slick tires specifically made for what we are doing, track days. Cup 2s are a high-performance track day tire that provides significantly more grip and dry than your standard road tires, all while being a lot more durable as they are designed for longevity and track endurance. Time to install them together with the wheel studs that I got from ProTrack.
Alright, the first step is to use a thread chaser and clean the threads. I mean, this is a brand new wheel hub, so it should be fairly clean, but we are going to chase it just in case. Okay, now a bit of brake cleaner. And blow it out. Then we have high strength thread locker. Apply it and pump it in. You also got to make sure that the threads are clean on the wheel studs. These particular wheel studs are torqued to 35 Newton meters, and we have an Allen Iverson here that we can use. I need a screwdriver to stab the brake rotor. And now it needs 12 to 24 hours for the Loctite to dry. Also, while I was in there, I removed the brake pads, cleaned them, and lubed them up again. That is something that you gotta do quite often on a track car. Wheels going on. I gotta test it. If it starts rubbing, we might need to lose the spacers. Clearing the strut. All 4 wheels installed, and I compressed the suspension on this corner and the one on the rear right, and now we can see that the tire is not rubbing anywhere and there's sufficient clearance, and it's the same thing on the back as well. So let's lower it down for the final time and torque the wheels. Ooh, it looks good. The fitment is so nice. Anyway, Torquenson time. 300,000 million Newton meters. Nice.
Another essential upgrade for the track, the racing brake fluid. After a bit of research, I landed on Castrol SRF Race Spec brake fluid. I was running ATE Type 200 fluid, which is a really good brake fluid. It hasn't given me any issues on the track, but I am being really hard on the brakes, and upgrading to full-blown race spec fluid is a logical step. Remember the chatter from the gearbox caused by the single mass flywheel that we talked about earlier? Well, this is the magical elixir that will help reduce the chatter. 50-50 mix of ATF, in this case from Liqui Moly, and 75W140 gear oil. But you can't use just any oil that covers that spec. It must be without friction modifiers, which is what we have here from Redline. The gearbox chatter was rather loud and pronounced on the idle, but adding this mix has notably reduced it. Nothing will eliminate the chatter other than a dual mass flywheel, but this dwindled it down to a level that is acceptable and pretty livable in my case. Can't recommend if you're in the same boat. A common issue when using the car hard on the track is a weeping power steering fluid reservoir. This is due to the PS fluid getting really hot, expanding and seeping through the cap on the top. I ordered this cheap aluminum lid from eBay that expands the capacity of the reservoir with an additional chamber inside that collects expanding fluid. I saw good reviews from other owners and decided to try it. I kinda wish it was black so it blends in better with the engine bay, but oh well.
Let's see if that works.
Now back to track speed yet again for a more aggressive alignment and more delicious camber.
So we're gonna go for how much camber in the front? What do you think?
3.5.
3.5? Good.
Bill did proper alignment to match the new grippy tires, but again he kept it safe and in line with my current driving skills. A massive thank you to Trackspeed for always accommodating me and doing a great job with the E46. We'll be back again at one point for even more aggressive alignment after I get more laps under my belt and get comfortable with the car. All of the stuff that you've seen me do in this video, I've done over the summer in between other projects. The final tune was actually only completed last week at the time of posting this video. Given that the fall is in full swing and winter is just around the corner, the season at the Nürburgring is at the end. I tried to sneak in a few laps last week, but the track was far too wet and slippery, and Cup 2s don't like cold and wet conditions. So here's some summer footage before the cams went in, but with Cup 2 tires. You can right away tell that the cornering speed's highly improved as the Touring has so much grip now thanks to the tires and alignment. With the mods that we've done, the lighter flywheel, suspension, brakes, seats, everything in general, the whole car is just beautiful to drive. With the power level that it has and the way it handles, it's the most fun car to toss around and drive quickly that I own. That said, we are not stopping here. In the future installment of Project Cologne, we are going to port the cylinder heads, two multi-angle valves, and slap S54 individual throttle bodies with a carbon airbox. We'll be chasing to break the alluring 300 horsepower mark. Besides that, I think it's time to do a full cage purely for my own safety. All of that is coming next spring when the track reopens again. I hope that you enjoyed this episode. Thank you so much for watching, and I'll see you in the next one, which should be on Project Marseille. Tschüss!